Hello everyone. Today we are going to solve the next question on bit manipulation concept. We have already solved the two questions. If you haven't seen that, please to watch that videos. And okay, so today's question is power of two. We have to check if the given number is power of two or not. So if the given number is 4, then we have to return true. If the given number is 6, then we have to return false. Power of 2 means a number can be represented in the form of 2 power x, where x is an integer. Okay, so we have to check that, and today we are going to solve this question using bit manipulation concepts. Okay, so if we check power of 2, like 2, 4, 8, 16, if we check it in binary representation, so 2 will be 1 0, 4 will be 1 0 0, 8 will be 1 0 0 0, and 16 will be 1 4 zeros. Okay, so if we check, we can see only one bit is set in the binary representation of any. If we check any number which is a power of 2, then in the binary representation of that number, only one bit is a set bit. Okay, so if we check binary representation of a number and it contains only one set bit, then we can return true or else false. So how we can check? The basic approach is just find all the bits and check and count the number of ones, and just like if count is greater than 1, we have to return false. If it is equal to 1, then we have to return true. Okay, so other than that, what we can do is, let's say if I take binary representation like this: 0 1 1, 0 1 1 1. If I do the AND operation of both, what will I get? I'll get 0. Right. So if I know this number, okay, and if I do this number and with this, we know only one we have in the binary. If we have this again once, let's say this is a number, this number has two ones, so it is not a power of 2 number. Okay, it is not a power of 2. Okay, so how we will check? We'll do the AND operation, then we'll get a non-zero number. Okay, so if it is a non-zero, that means it is not a power of 2. If we get AND operation of these two numbers, if we get 0 as output, then we can say it is a power of 2. We have to return true, and if it is not, then we have to return false. So how we can find this number, right? So what we can do is, let's say we have 8, number 8. This is 8. What is this number? It is 7. This is 4. What is this? This is 3. This is 2. This is 1. So we have to do n and n minus 1. If we get 0, then we have to return true. And if we don't get 0, then we have to return false. We got the concept right. We got like what we are doing. We are given a number n. We have to subtract it by 1, so we'll get this. Like we have to unset the bit other all other than this one. So we have to, uh, like if we see the pattern like n and n minus 1, we'll get this pattern. And if we do the AND operation of these two, we'll get a 0. Then we can say it is a power of 2. And let's say an example 6. If we represent 6 in a binary, how we can represent it? 4. Okay, so this is 4 plus 2 is 6. This is 6. If we represent 5, like n is 6, so n minus 1 is 5, so it's 101. If we do the AND operation of both, what we'll get? 100. It is not a 0, right? It is a non-zero number, so we are returning true. So this is the first approach using bit manipulation. What we are doing, n and n minus 1. If it is 0, then we are returning true. If it is not 0, we are returning false. Okay. Okay, so here I did one mistake. I have to use the brackets. Yeah, you can see yes. Yeah, so here the input is 1. So input 1 is 2 power 0 is 1, right? So it is also 2 power. If I check with 16, yes. If I check with 15, no. Okay, we are getting the answer, right? So now this is the first approach. We have to see the second approach, the efficient approach. Okay. So yeah, this was only the efficient approach. We have already seen the first approach, which is a brute force approach. We have to count all the set bits, like how many bits are set in a binary of a particular like given number, and if it is greater than one, then we have to return false, and if it is equal to one, then we have to return true. And again, we have to add one condition: n should not be equal to 0 and n. Okay, because n is equal to 0 is it should return false, because 0 is not a power of 2. Power of 2 starts from 1, like 2 power 0 is 1, 2 power 2 is 4, 2 power 1 is 2, right? So in this way. Okay, so we are done with this question. So yeah, thank you.